Let's start a new chapter. And in the first section, we will talk about addition property of equality. So first objective, we know what is the addition property. So if A, B, C are real numbers, then we have this property. A equals B. This is an equation, right? And we should know A plus C is equal to B plus C. We do the same thing to both sides of the equation. Both sides we plus C, so the equation is still true. The same thing, if A equals B, we minus the same number for both sides of the equation. This equation is still true. So we can use this rule to solve the equation to find the solution of x. Let's check the example. If we have this equation x minus 7 equals 10, we want to solve it. We want to find the x value here. So basically, we can do the same thing to both sides, right? We add 7 to both sides of the equation. Then the equation remains the same. So, but minus 7 plus 7, we can cancel out. After that, we can get the solution of x. So both sides add the same number will not change the solution of x. Next step, we can check another example. So this is almost the same one as the previous one, but this time, because here we have minus 5, x minus 5, so both sides we add 5. Then we will cancel out minus 5 plus 5. We only keep x equals 13. Then x equals 13 is our solution. Of course, we can also check our answer. For the first equation, we can check if x is equal to 17 is our solution. How can we check if this one is our solution? Remember, we just use 17 to replace x for the first equation. So we use 17 to replace the x. So it will be 17 minus 7 equals 10. Then we can check the left side first. For the left side, we get 10, right? And right side is also 10. And then we know the last statement is true. So we confirm this is the solution. We can do the same thing for the second equation. How can we test if 13 is our solution? We just use 13 to replace x. Now x minus 5 will be 13 minus 5. Then we check the left side. Left side, we get 8. Then we check the last statement. 8 is equal to 8. Yeah, it's true. So we confirm 13 is our solution. Okay. So let's try another example. This time we have decimals. But we still do the same thing. This time we want to solve y. Solve for y, then we can do this. We minus 0.6 to both sides. Then we can cross out plus minus 0.6. We keep y equals negative 1.6. Okay, after that, you can check if you do it correctly or not. So we can test. So y, this time we use negative 1.6 to replace y. Plus 0.6 equals negative 1.0. Then we check left side first. Negative 1.6 plus 0.6. So we already know it's negative 0, or negative 1.0. We check if this statement true. We got left side equals right side. So it's true. We confirm y equals negative 1.6. Yes, it is our solution. So this is about decimal example, and if we have a fraction, the rule is still the same. If we want to solve for x, so we want to make x alone, right? So both sides we add 3/4. Because if we do this one, we can make x alone, because negative, positive will cross out. So we only have x is equal to 5/4. Now we use this answer to check if it's correct or not. 5/4. Now we check the left side. Oh, we have 1/2. In the right side, oh, it's 2/4. Now we know it's true. Left side is equal to right side, so we confirm our answer 5/4 is correct. Okay, so let's check another one. So another example. This time we have 5t minus 5 equals 6t. So we want to make 1t on one side, right? We want to keep 1t on one side, and we hope another side do not have t. So we can do minus 5, then minus 5t for each side. So for the left side, we have 5t minus 5t. We can cancel out. So negative 5 is equal to 1t. So we just put t here. Then we try to test if our answer is correct or not. So we use negative 5 to replace t. Let's check. It will be negative 25 minus 5. It will be negative 30. So let's check the statement if it's true or false. So it's true. Negative 30 equals negative 30. So we confirm. This is our answer. Okay, let's move on to objective B. We want to simplify. Simplify. So let's check the example. If we have this one, 2x plus 3x minus 5 plus 7, then we have another side. So we can combine the like term on each side. So for the left side, we can combine 2x plus 3x. Then we will have 5x. Then we combine the numbers. Minus 5 plus 7, we will have plus 2. And we can do the right side. So 10x minus 6x, combine them together, we will get 4x. Then combine the number. Plus 3 minus 4, we will get minus 1. After that, we want to keep the x on one side, right? So we will do both sides minus 4x to make the x disappear on this side. Or if you want, you can write like this way. Minus 4x. So after we do that, 4x minus 4x will be cancelled out. So we combine the left side. 5x minus 4x. So we only keep x. X plus 2 equals negative 1. Then we want to separate the x. We can minus 2 for both sides. Then plus 2 minus 2 will cancel. So only x equals negative 3. Okay? If you want, you can check your answer. Just use negative 3 to replace x in your equation. Then you will realize we did it correctly. Alright, so we can try another one. This is another example. This time we have this. So 7. So this time we should use distributive rule, right? So for the first term, we will use distributive rule to get this. For the second one, we will have. Then for the left side, we can combine 12a and negative 11a. We will get 1a, so I just put a here. And combine minus 6, another minus 6, we will get minus 12. We'll get 7. So both sides, we can add 12. We can add 12 to both sides. Now we can cancel out. Only a is left. So a is 19. Okay, that's for the simplifying. Okay, of course you can still plug it into your equation to test if 19 is your solution. Okay, objective C is try to writing the expression. So for example, if we have this one, sum of two numbers, we want to sum of two numbers is 8. One number is 3. Find the other number. We should use the expression to express the other number. So we know sum of two numbers. So it will be like this one. Sum of two numbers. We translate the sum into addition is equal to 8. Then 1 is 3. Right? So we know we want to see what's the second number. So we already know if we treat this one like a, we know a should be equal to 5. Or we can use a is 8 minus 3. So it's also 5. Similarly, if we can use this time, we have the sum of two numbers is 8. And one number is x. We also need to find the other one. So we still have sum of two numbers is equal to 8. But this time, one of the number is x. So how about another number, a? So we can also use this to represent, because the sum of two numbers is 8, and 8 minus one of the number x to get another number. So we can find another number is 8 minus x. Okay? So we can check another one. This time is the sum of two number. Sum is 11 of two number. Yeah. And one number, one is x. The other one, we want to know the other one, right? So the sum of two number is 11, and the one is x. So how can we get to the other one? We know the sum is 11. Only need to use sum minus one of the number, we can get the other one. So 11 minus x is equal to 11. 11 minus x is equal to the second number. Okay, it's kind of like the factor family, you know? So that's for 2.1. We can check another one. If this time sum is 56, one number is a, the other one is, okay, so we can put sum of two number is equal to 56, and one is a. How about the second one? We know we use the total sum minus one of the number to get the second number. So it will be 56 minus a. All right.